This network of genomic surveillance last year detected a new coronavirus lineage, which later became known as the Beta variant. Now, a new variant has been identified and assigned the name Omicron. Joining us now to talk about how these variants are identified, managed locally as well, we're joined by Principal Medical Scientist at the National Institute for Communicable Diseases, Dr. Jinal Bhiman. Dr. Bhiman, a very good evening to you, and thank you for your time on this Saturday evening. Let's begin with the basics, the identification of a variant and the sort of sampling that has to take place in order to get a conclusive result.
Good evening to you and to the viewers. So actually, I think the identification of this variant was a little bit different to what we do routinely. You know, we routinely sequence specimens that test positive. We randomly select samples from multiple different testing labs and just routinely sequence every week. But with this particular variant, we actually got a signal from the testing labs themselves, from the diagnostic labs themselves, because as you're probably aware, the diagnostic tests for SARS-CoV-2 target different genes of the virus. And so the diagnostic lab started seeing that one of the genes was not being picked up. And this immediately raised a flag for them, and they prioritized some of these specimens for sequencing. And that's actually how this particular variant was identified.
So you see it then, but I'm wondering, and perhaps this is a simplistic question, about the quantity of the same pattern, the consistency, shall we say, of the same pattern that you would need to say, hold on, there seems to be a greater problem here.
So typically, like in our previous waves and even in the lull periods, for the most part, most of the gene targets amplify. Most of the different genes that are picked up in the PCR amplify. But in this situation right now, the last 3 or so weeks, firstly, we started seeing a sudden increase in the number of cases. So the diagnostic lab started seeing this rapid increase. And secondly, they started seeing that this one gene consistently and in quite a large number of samples. I mean, currently it's greater than 90% of the samples are not being amplified on this one gene target. So that's a huge change from the norm. And so, yeah, already that was widespread. That was more than 90% of the positives that were coming up were missing this target. And then in terms of the actual sequencing, we started off with 8 sequences last week Friday, and right now we're up to 115.
So are you saying there are 115 cases of Omicron specifically in South Africa?
Well, 115 confirmed by sequencing. But in terms of the diagnostic tests and in terms of the S gene dropout, as we call it, that's much more. That's many more cases. Almost 90% of cases in Gauteng. And
you mentioned the issue of Gauteng. One thing that was said in the initial briefing where this news of the detection was confirmed is that, yes, we're seeing it spread, especially around the Tshwane area here in Gauteng, but in all likelihood, the variant is likely to also be present in other provinces as well.
Yes, we do have confirmation that it is in most of the other provinces. There are a couple of provinces that are not using assays that target the S gene, and so that's why we're not picking them up in those provinces. But those labs are now sending their specimens to other labs that do use that assay to confirm whether the Omicron variant is in I think the 2 provinces at a couple of days ago now were Western Cape and Limpopo, but we definitely have confirmation at this point from Western Cape that they're seeing this S gene dropout, as we call it.
We've seen all the international fallout from this, everything from travel bans to the rest of it, right? Do we simply have to accept that because of, shall we say, our advanced genome sequencing, we're likely to always, well, not always perhaps, but regularly face the sort of punishment, as it were, for being the first to detect announced and therefore being the targets to a degree of the travel bans and those decisions?
You know, I think I feel very demotivated and probably very saddened by this, as most of the other people in the country feel. But this is really beyond our hands and beyond the hands of our government. This is now other governments that are, you know, as everyone has said, knee-jerk reacting. It's not rational at all. And so I don't understand, you know, how governments can justify these kind of actions, especially when they know the economic situation of countries in Africa, including South Africa.
As far as global information sharing on new variants and other updated COVID-19 information, Doctor, how much of that goes on? Is it all primarily within the confines of the World Health Organization, or is there more of a country-to-country relationship?
It's actually much bigger than through the World Health Organization alone. So there's actually currently a database that pretty much every single country who does genomic surveillance for SARS-CoV-2 uploads their sequences to. And a lot of the times this is done on a regular basis, on a weekly basis, on a monthly basis. So, and once it's uploaded to that database, it's a public database. So literally any single person, whether you're a scientist or not, can have access to that data. So the sharing is much broader than that.
Look, this sentiment that we've seen circulating online sounds as something that's not as ethical as it should be. I mean, I'm sure you've seen it as well. People tweeting and Facebooking saying other countries are probably sitting on latest information about the detection of new variants. Why does South Africa have to speak up? Let's talk about why it is important to make the information public as soon as it's available.
So I think, we're in a pandemic situation, and withholding information is only going to add to all the negativity, all the complexities. Sharing information means that, for example, in South Africa right now, we are working towards making our own mRNA vaccines that will incorporate this variant sequence. So that's what it means. It means that we can all progress, we can all move forward, towards ending this pandemic and towards going back to some sense of normalcy. I disagree with withholding information as a scientist and just as a person in general, especially in a pandemic situation.
And how much longer might we have to wait for information on, in fact, accurate data that can speak to how transmissible Omicron is and the response to the available vaccines?
I know for a fact that our colleagues in KZN have already started trying, and in the Western Cape actually have already started trying to culture the virus, so to grow it out of specimens. That I hope will take a week or two before they can actually start testing vaccine plasma and convalescent plasma, blood from individuals who had been previously infected and blood from individuals had been vaccinated, to see what is going to be the impact of these mutations on vaccination. So I would say let's give it another 2 or 3 weeks, and hopefully we'll have some data. In terms of the transmissibility, that might be a little bit more tricky to answer. I think most of the scientists currently looking at the mutations in this variant, we think that most of these are immune escape mutations, and that immune escape is what's driving, so to say, the number of cases rather than transmissibility. But yeah, that's a little bit of a more tricky question to understand. We obviously need to have large numbers of individuals infected, and we need to study, for example, household transmission and things like that to really get a good handle on transmissibility.
Dr. Bhiman, we'll have you back on the show to explain that once we have that more available data on transmission as well as vaccine efficacy. But for now, thank you so much for being on News at Prime.